Hello, everybody.
Yeah, sure.
I'm Stefano Bovio, and working as a front-end developer at GeoSolutions. The company is based in Italy and US, and we are mainly working with open source products like GeoServer, MapStore, GeoNode, and GeoNetwork. And what we do, we design, develop, and deploy end-to-end scalable, interoperable, secure geospatial solutions. An introduction on what's MapStore. MapStore is an open source WebGIS framework, so it's a web app application where it's possible to plug in different tools and allows you to create from the user interface maps, dashboard, and geostories. It's written in React.js and it's mapping library agnostic, so we can build a different type of mapping engine on top of it. The one that currently supporting are OpenLayers, Leaflet, and CesiumJS. On the images on the right is the UI of the map viewers, and from the toolbar at the bottom, it's possible to switch to the 3D view that will load the CesiumJS viewer. We included Cesium in MapStore in the 2016 for the first time, and since then we are improving it and on the MapStore side to support as much as possible all the Cesium functionalities. So we started to include all the available layer types and also extending the one that was requested from external contributor. The contributors where we collaborated with are public, for example, Italian public administrations, organizations worldwide. Here are a list of few of them because we're including in the screenshot their work and a preview of some of the functionality that we implemented. In this presentation, we selected a few of the features that we included in MapStore to extend the functionality that Cesium has. So we used the Cesium API and created a part from the UI, but also in the code part that we'll share now, these macro groups that are selected here. One of the requirements from the contributor was the implementation of map views. The use case that often were requested is we have 3D tile assets, that is static assets, and that represent the current situation of the city. In the images on the right, you see the Genoa city. And both of these, they wanted to include like the state of a project that was evolving in the city, from the master plan to the structure underground and so on. So we included for the map viewer, the possibility to have the views, so to calibrate the camera, so to select the camera position and allow to hide or clip the layers. And a few years ago, we used, looking also in the discussion on the Cesium forum, there was the proposal to use the clipping planes. So we ended up to integrate this logic inside our framework, and with some limitations. So at the time, we can clip just one area at the time, all the convex shape. And right now, we're seeing that Cesium, in the latest version last year, included the possibility to have clipping polygons. So this will help us also to have a more granular way to show evolution inside the urban environment. Here an example on how they used it. This is Genoa city. They reconstructed the coastline. The white coastline side is 3D tiles of historical data. They wanted to see the location where was before of the lighthouse of the city. So one of the tools that they used was the map views plus the clipping functionality that we implemented on top of Cesium API inside the MapStore. Here's another example, always from the city of Genoa, where we are clipping a subway station with a diameter of 15 meters, and each view gives also the possibility to use additional tools. In this case, for example, using clipping to highlight an area, and then using measurement tool to inspect and analyze this part of the urban environment. This brings to the second main argument, that is the drawing system. One of the main requirements was to include in MapStore, using the Cesium viewer, a way to annotate, so make annotation, and also certain type of measurement. So the idea here was to create a 3D drawing system that support base shapes like base geometries like point, line, string, and polygon, and build this as a React component that we can extend in different tools. Here, just to mention a few of the API that we used the screen space handler event to intercept all the mouse event. And then we also use, in this case, primitive collection and billboard, because we found out that were more performant in the viewer, so it was more fluid to use that instead of entities. So this was the approach that we used that. On each of these slides, there is also a link below to the actual code that we implemented, so if someone is interested to see that. One major part that for us was difficult to get, but at the end we found a solution, was how we can pick points inside a view. So how can we draw on top of features all the globe? And we came up with this fallback picking idea. So to have try, first of all, with the pick position of the scene. If that fails, we go with the drill pick from Ray. And at the end, fall back finally to the globe pick to get the feature that we intersect and the Cartesian cartographic positions. Then we wrapped this class that we implemented inside a React component. So we were able then to reuse inside the different tools that we have. Here an example of the UI. This is from the municipality of Florence. This is the interface of the map viewer with the table of content on the left. I think this one was an event, yeah, the Tour de France event. So they have all the layers mixed together, like WMS that represent the area that was limited for some reason. And here we are showcasing the usage of the measurement tool implemented on top of Cesium inside MapStore. Another example of the 3D drawing system in use, here it's for the annotation tools. So the idea is to use the drawing system to apply like text, 3D models or extruded area inside the 3D view. We added this, and that was not just a part of drawing, so creating the feature itself, but also a part of styling. So also the styling was another major work that we did to use as much as possible what Cesium could provide us. And in this case, what we try to do is to use the same structure that we have already. We had a styling system based on a JSON instruction that was divided by symbolizer. It's a version from a library called geostyler. So we were using the JSON structure plus the UI that was easier to then create all the components that we have in the UI. And behind, we created style parser and the classes to manage this type of styling. For example, one thing that we need to do is to create a specific custom data source to manage the entities and primitive. Because in the structure that we have, we expect to have for each feature, so we could have multiple type of styling. So we can replicate multiple type of styling. Before we were using the GeoJSON data source, but was limiting because we have just one-to-one feature to style. So we end up to wrap the data source class to a custom class, then to manage also other functionality like the filtering system. As in the image below, we are using the table of content to filter feature on top of the map. Another example of usage of styling plus 3D tiles, here is a mix between the 3D tiles of the building's volume. Then we use a WFS layer placed on top, and here it's showing the degradation of the vertical surface. Or another example, the same style editor with the structure of the styling that I showed before, but instead apply to the 3D tiles. This last part, we want to mention a few layers that we worked inside the framework system. One request was the addition of a layer to support ISC model, and was used also in combination with the clipping system, so showing a project from a CAD software inside the 3D Cesium view. And here we use the WebGIS library, open source library, to parse from a URL an NFC model. And also in this case, we had to create primitive, and all the meshes placed on two big primitives, one for the translucent, so the surface that are translucent, and one opaque. We tested both, in this case, entities and primitive, but at the end, the primitive was the one that was keeping a fluid navigation in the Cesium viewer, so we end up with those. This is an example of the model, and even if we are using two primitives, we're able also to retain information metadata for each element of the building. So you can query, like this is the windows, and you have the metadata associated with that. Finally, another type of layer that we included using the API from Cesium, but also externalized API. We included the possibility to have different providers for the terrain support. And at the moment, we have the Cesium that using quantized mesh, Cesium Ion, and the WMS. WMS, there is a library that supports the build data and allow to include a WMS layer like a terrain layer. And this is an example of the viewer that it's using the quantized mesh from Cesium, and where we are currently implementing the management of the terrain through background list selector. Here, finally, if you want to try MapStore, as I mentioned before, it's open source as a permissive license, so you can download it, use it, and there is a link to the documentation, the repository, and the latest release. Or if you want to test directly on the browser, there is the demo link, the last one, that can be tried directly from the browser. That's all, and thank you if there are questions.